Okay, so the last sort of big topic, or the last formula case, is the annuity, what's called an annuity. It's how pensions work once you're retired. Annuity formulas can also be used for installment loans, but the first part is the annuity part. And the idea is you have this large amount in an account. Alright, so you have this large present value in an account. So large present value. And then you're going to withdraw the money, but you're not going to withdraw it all at once. You're going to withdraw it a little at a time. Right? A little bit at a time over so many years. At the end of the years, the end of the time, you will have nothing left in the account. The future value will be zero. So you start with a large amount. You take out regular withdrawals, regular payments out of the account, until at the end of time, you've taken out the very last amount of money, which is your payment. Right? You've got zero in there. This is how retirements work. You save up, you use your accumulation function. You save up to a large amount that once you retire, your 401k, your IRA, or whatever it is that you've retired into, is saved, and it's still sitting in the same account, so the same investment. But then once you retire, once you've hit the retirement years and you're allowed to withdraw from it, then you do that. And so what you do is you live off of that retirement. So when you retire, you take out the same amount of money, usually monthly. So you take out, $1,200, $3,000 per month to live off. So that's your income. Your income's coming from the amount of money you save while you're working, so you can retire. You have an annuity, a pension that's set up for so many years, right? It's not an infinite amount of money, right? You only have the amount of money that you've accumulated in there. And so usually you set up your retirement for 25 to 30 years, right? Usually you retire in your 60s and you hope to live, into at least your 90s. And so usually you have a 30-year period there. But at the end of the 30 years, the annuity will basically be exhausted. Right? There would be nothing left in there at the end of the time period. So if you lived past your annuity, hopefully you had more than one pension plan. Or have kids. Installment loans also work this way. And installment loans are annuity from the bank's point of view. And so this is the way most loans work. It's the way your college loan works. If you get a car and you take out a loan, that's how a car loan works. Buy a house and get a mortgage, that's how mortgages work. Any loan that you get from a bank, an establishment, are installment. It means you're paying them back in installments. And they are this annuity part from the bank's point of view. You borrow a large sum of money. That's the present value. So you take out or you borrow a large sum of money, and then you pay it back making installments, fixed payments every month over T years. At the end of the T years, you've paid off your loan, and so you owe them zero. And so the setup is exactly the same. It's just a different point of view, but the formula is identical. You borrow a present value, you pay it off slowly, over, small installments over usually months, for however long your loan is. At the end of your loan period, as long as you didn't miss any of your payments, you paid it off and you owe them nothing, right? You've paid off your loan, so future value is zero. So it's the same equation, identical calculations for loan installments and annuities. All right, it's just so you know that the WebAssign in the book will call those annuitizations, for instance, to pronounce that right. But it means the same thing. They're annuities and installment loans. Alright, so just so you know what's going on in the formula, and I will do one example with the formula, and then after that we'll use our Tvm Solver. Alright, so here's the formula, and so if you recognize, you look at the formula, there's no future value in this formula at all. Right, because future value is zero. At the end of time, there's nothing left in the account. You've exhausted the account. Alright, you do have payments. Those are your withdrawals. The payments are your withdrawals, or your payments to the bank. Right, you're making the debt smaller, right, when you're paying it off. So they're payments, withdrawals, the same thing. You're paying off your loan, or if it's the pension, you're withdrawing from your pension. All right, so those are the PMTs. And then the rest of it has to do with how the money works. So again, inside the formula, it has to do with your I, which is again your interest rate. All right, I is your interest rate over your compounding period. N still represents payments. It's your compounding period times time. This would be your total withdrawals or payments. Alright, So it'd be the total payments you make back to the bank or the total number of withdrawals you've paid out of your pension. Alright, so those are the same thing. I is still, again, in there. And again, it is a little more complex, and this is a negative that goes up in here. So again, I'm going to do one of these, but I'm going to assume that after this you're going to be using the Tvm Solver. But it's important to understand how what the Tvm Solver is doing. It's solving this formula. Alright, so suppose your grandmother is offered to help pay for a little bit of your college. She opens an account in your name. She plans to deposit a lump sum of money. Alright, so you can make withdrawals of $10,000 every 6 months from the account for 2 years. How much should Grandma deposit now so that you can make the withdrawals? The account will be empty after the last withdrawal. Assume the account earns 5% interest, compounded every 6 months. Alright, so there's all of the important information. So what's going to be hard about, and I'll do a mixed notes example, because what's hard about this isn't really a hard. Chapter 2 is an easy section. Plugging it in, filling out the Tvm Solver is easy. The hard part is recognizing all the different cases. Is it an annuity case? Is it a pension case? Is it a sinking fund case? Is it a compound interest case? Is it a simple interest case? And so you kind of, highlighter's not a bad idea, or for you guys it'll be more writing down the information on a sheet of paper or scratch work. But the biggest thing is we have a present value. We start with a lump sum, right? We deposit a lump sum, so that's what we want to figure out. We want to figure out the present value, right? What sum should Grandma deposit? Compounding period is every 6 months, so twice a year. Our interest rate is 5%, so written as a decimal, because I'm plugging it in the formula. Our time is 2 years, and we want to figure out the payments, right? The withdrawals in this case. And so those are what's giving it away that it's an annuity case. I start with a large sum. I'm slowly making withdrawals over the last 2 years, and then this is also a clue that it's the annuity case. The future value is 0, right? There's nothing in there at the end of 2 years. You used up all the money. All right, well, we want to know what payments every 6 months, how much money can you take out of Grandma's account? And so we're looking for the payments. And so using the formula to do that, so remember the formula is present value is our payments times 1 minus 1 plus I raised to the negative n all over I. Alright, and so I'm going to figure out what I is, so it's a little easy, and n is, it's a little easier to plug it in if I know what those are. Alright, so I, remember, is our interest rate over our compounding period, so that comes out 0.025. And n is our compounding period times time, which is 2 times 2, so 4. Alright, so you're going to make 4 withdrawals. You're going to get 4 withdrawals when it's all set. So 4 times, you're going to pull out 1,000, or 4 times. Oh. I know what the withdrawals are. Why I said I didn't. I'm going to pull out $1,000. I know what the $1,000 are my withdrawals, right? I'm taking $1,000 out. And so 4 times, you're going to get $1,000. So it means $4,000 is what you get, but Grandma doesn't have to put $4,000 in the account. She gets to put a little less than $4,000 because some of it's going to come from the interest rate. Alright, so carefully plugging in all of the information into my formula. So I'm looking for present value. My payments are $1,000. 1 minus 1 plus 0.025 raised to the negative 4 all over 0.025, my interest rate. Alright, so they're carefully, and again, I put extra sets of parentheses in there just to be the safe side. The set that you have to have is the big set there, and then the set around the 1 plus. Alright, then you carefully type it in. If you carefully type it in, it should come out, just to kind of logically speak, you're going to withdraw $1,000 4 times. Alright, you're going to make 4 withdrawals, so you're going to pull out 4 times $1,000. So altogether, you get $4,000 from Grandma. But some of it's most of it's Grandma's money, but there is some of it that's coming from the interest rate. And so the value should be less than $4,000. Alright, because I get $4,000, but some of the $4,000 came from interest. And so it does. If you type this in carefully into the formula, it comes out $3,761.97. And so that's how much Grandma puts in there. That's the sum invested. You get 4,000, right? Because you get to pull out 4,000 altogether. Altogether, you're doing it a little bit at a time, but altogether you get to pull out $4,000. All right, so there's the formula example. So that's how we plug it in if you're using the formula. Now I'm going to go to the Tvm Solver case, which is the case that I would assume most of you will use. All right, so suppose you've won the lottery, and this is how they ask you if you want your lottery winnings in installments. This is what they're talking about. They're going to do it as an annuity. They're going to set it up as an annuity, right? See those commercials? I want my annuity now, or whatever. It's because people are trying to take all the money out instead of getting it a little bit at a time. An annuity is where they've set it up and they've put this amount in the account, and they're just going to give it out a little bit at a time. Instead of all $1 million that you won, you're going to get it out in installments of $50,000. Alright, so you won the lottery. You won $1 million. Suppose it was $1 million lottery. Instead of giving you $1 million all in once, what you're going to do instead is over the next 20 years, they're going to give you installments of $50,000. If you take 50,000 times 20, you get your million. You just get it a little bit at a time over 20 years. You get it, $50,000 annually for 20 years, for the next 20 years. And so the reason why they do that is because they don't have to shell out $1 million that way. They get to shell out a much smaller amount, a significantly smaller amount, into an account that will earn interest, and you'll get your million. And then some of the stuff that they'll get is coming from in the bank, from the account they're using to set up your annuity in. All right, so we want to figure out, well, how much is that amount? How much should the lottery officials deposit now? That would be your present value. In an account earning 4.9% compounded annually, because again, you're getting a yearly payout, so you've got to set it up annually in order to make the payments. Alright, so then the Tvm Solver, so just carefully plug it in. It's set up similar to what we did before, except now at the end of time, right, at the end of the 20-year period, you would have pulled out all of the money. And so the future value, so what you've got to remember is future value is 0 in these cases. At the end of 20 years, you've taken all of the money, taken all $1 million, and there's nothing left in there for you at the end of 20 years. So future value is 0. Right, then your payments, those are withdrawals, and this time the payments are positive because you're withdrawing that amount. They're giving you $50,000 a year, and you can go spend it however you like. You could reinvest it, you could buy a car, you could do whatever you want with your $50,000, so it's yours to spend. And so that's why it's positive. All right, the payments are withdrawals you can spend. All right, it's now in your pocket, all right, so to speak. It's put in your pocket and you can go spend it. All right, so your payments are positive in this case. I think I might have done one extra zero. All right, 50,000, 4 zeros. All right, so payments are positive, 50,000. Your present value, well, that's what we have to figure out. That's what we're going to solve for. How much money do the lottery, again, it should be significantly less than $1 million. You're going to get $1 million, but you get it a little bit at a time, so some of it comes from interest. I was 4.9, M is still our compounding period times time. Compounding period is 1, time is 20. All right, 20 pay periods. You're going to get your money 20 times, $50,000. And it's invested once, right? So these are 1, right? Yearly payouts, compounded annually, which means yearly. So those both should be 1s. And then you solve for that present value. It's still a pretty big number, but it's significantly less than $1 million. So if you carefully type that out, the present value does come out negative because you can't touch the big number. Right? This is a fairly large number. It comes out negative $628,427 and about 94 cents and change. It's negative because that little over $500,000 there, you can't touch it. You can't pull it all out. You can't go to the bank and say, I want that $600,000. You can't do that. You get $50,000 every year for 20 years. You can't take that money out. It's sitting in there earning interest for 20 years. So for 20 years, there's money in the account. At the end of 20 years, it's zeroed away. All right, so that is why it's negative. It's money you can't touch. Which again, this is why they do this. They only have to shell out a little more than $500,000. The rest of the money, which is about $300,000, $1,000 in interest. Right? They have to shell out about a little over $600,000, and the rest of the money, the rest of the million, comes from interest. And so that's why they prefer installment loans, because it's the cash flow is a little easier. They don't have to actually give you $1,000,000. They give you that with interest in small payments, and you get $1,000,000, but it just comes to you in small payments. All right, and so that's the annuity case in terms of lotteries. All right, we'll pick that up in the next video. We'll do a few more examples of the annuity case.